Hello everyone. Today I am there with the one shot video of chapter Coordinate Geometry. Hope this video will be helpful to you. So let's understand the concept. Before moving to the concept of this chapter, let's recap the basic knowledge of coordinate geometry which you had studied in the previous classes. Coordinate geometry is the location of a point on a plane which is expressed as a pair of x and y. So here the point is referred as x1, y1, and these pairs are known as the coordinates. So the first value is always the x coordinate, which is referred as abscissa, and the second value is always the y coordinate, which is referred as ordinate. So here x coordinate denotes the distance of this point from the y-axis. So here this point is at a distance of 3 units from the y-axis. So the x coordinate, the value of x coordinate is 3, and y coordinates denotes the distance of this point from the x-axis. So here the distance of this point from the x-axis is 4 units. So the value of y coordinate is 4. So the coordinate of this point is 3 and 4. Let's see the sign of abscissa and ordinates in different quadrants. So here the Cartesian plane is divided into 4 quadrants with the help of the x-axis and the y-axis. So the first quadrant is formed with the help of the x-axis, positive x-axis and positive y-axis. So the x coordinate is always positive and even the y coordinate will be positive. For second quadrant is formed with the help of negative x-axis and positive y-axis. So the x coordinate is negative and the y coordinate is positive. The third quadrant is formed with the help of negative x-axis and negative y-axis. So the x coordinate is negative and the y coordinate is negative. And the fourth quadrant is formed with the positive x-axis and negative y-axis. So the x coordinate is positive and the y coordinate is negative. So the point at which the x-axis and y-axis intersect, this point is said as the origin, and the coordinates of this point will be 0 and 0 because this point is on the x-axis and the y-axis. So the x coordinate is 0 and the y coordinate is also 0. So the coordinate of the origin is 0 and 0. Coordinates of the point on the x-axis are x0. So if I take a point here on the x-axis, so the coordinates of this point will be, as it is x0, so here x coordinate is 4, so coordinates of this point will be 4, 0. And the coordinates of the point on the y-axis are 0, y. So if I take a point on the y-axis, then the coordinates of this point, as it is said here, it will be 0, y. So here 0 and the y coordinate is 5. So it will be 0, 5. Let me explain again why is it so. Let me take one more example. If a point is on the x-axis, then as I said that here x and y coordinate, x coordinate is the distance of the point from the y-axis, that is 3. So the x coordinate is 3 and y coordinate is the distance of the point from the x-axis, and since the point is on the x-axis, so the distance is 0. So here the y coordinate will be 0. That is the reason we say that here when the point is on the x-axis, then the coordinates of that point will be x0. In the same way, if I take a point on the y-axis, So here the coordinates of this point, we are going to refer it as x coordinate is the distance of the point from y-axis. And since the point is on the y-axis, so the distance of this point from the y-axis is 0. And y coordinate is the distance of the point from x-axis. So the distance of this point from x-axis is -4. So here the coordinates of this point is 0, -4. So we refer the coordinates of the point on the y-axis as 0, y. Now let's have a quick recap. Here the coordinates of this point are 2 and 3. So the x coordinate is 2 and the y coordinate is 3. And the coordinates of this point is -3, 1, x coordinate is -3 and y coordinate is 1. And the coordinates of this point here is -1.5 and -2.5. So here x coordinate is -1.5 and y coordinate is -2.5. And here, since this point is the origin, so you all know that the coordinates of the origin are 0 and 0. If I mark a point here, then the x coordinate will be 3 and the y coordinate will be -2. So the coordinates of this point will be 3 and -2. So if I take a point here on the x-axis, then the coordinates of this point will be 3 and 0. So here the x coordinate will be 3 and the y coordinate will be 0 because the point is on the x-axis. And if I take a point here on the y-axis, then the coordinates of this point will be, since the point is on the y-axis, so x coordinate will be 0 and the y coordinate will be 2. So the coordinates of this point are 0 and 2. So now let's move to the concept of this chapter, that is the distance formula. So the distance formula is used to calculate the distance between the two points. If I say that the 2 points are there, A and B, so to find the distance between these 2 points, we use this formula that AB is root of x2 minus x1 whole square plus y2 minus y1 whole square. So here coordinates of these 2 points are given here as x1 y1 and x2 y2. To find the distance formula, you construct a right angle triangle, that is draw BM perpendicular to x-axis and draw AC perpendicular to BM. So we get a right angle triangle, that is ABC. So here to find the distance of this AC, you mark this point M as, here since the x coordinate is x2, so here this mark it as x2. And here since the x coordinate of this point A is x1, so write here x1. And the y coordinate is y1, so mark it here as y1. And the y coordinate of this B is y2, so write here y2. And the coordinates of this point C will be x2 and y1. So now here the distance of this AC will be x2 minus x1. So AC is x2 minus x1 and the distance of this BC will be y2 minus y1. So that is BC is y2 minus y1. So here since ABC is a right angle triangle, so we are going to use here Pythagoras theorem, and AB is the hypotenuse. So AB square will be equal to base square, that is AC square, plus altitude square, that is BC square. So here AC is x2 minus x1. So AC square is x2 minus x1 whole square plus BC is y2 minus y1. So BC square will be y2 minus y1 whole square. So we got AB square as x2 minus x1 whole square plus y2 minus y1 whole square. Shift this square to the other side. So we get AB is equal to, this square becomes root to the other side. So it is x2 minus x1 whole square plus y2 minus y1 whole square. So that's what this distance formula is being derived. That is AB is equal to x2 minus x1 whole square plus y2 minus y1 whole square. So here order doesn't matter. We can write this as AB is equal to root of x1 minus x2 whole square plus y1 minus y2 whole square. So here order doesn't matter, where you can write it as x2 minus x1 whole square or x1 minus x2 whole square. Here y2 minus y1 whole square or y1 minus y2 whole square. Order doesn't matter, both are same. For example, if I take x1 as 3 and x2 as 1, then x1 minus x2 whole square will be x1 minus x2 whole square will be 2 square, that is 4. And if I take this x2 minus x1, if I change the order, then it becomes here 1 minus 3, because x2 is 1 and x1 is 3. So 1 minus 3 whole square, that is minus 2 square, which is also 4. That is the reason I said that order doesn't matter. You can change the order as per your convenience. Just see how to find the distance between the 2 points using distance formula. So here if I take the point A as 3 minus 4 and the point B as minus 2, 5. So to find the distance between this AB, we are going to use the distance formula, that is x2 root of x2 minus x1 whole square plus y2 minus y1 whole square. Mark this point A as x1 y1 and this point B as x2 y2. So use the formula here, root of x2, that is minus 2, minus x1 is 3 whole square plus y2 is 5 minus y1 is minus 4 whole square, that is equal to root of minus 2 minus 3 is minus 5 square plus 5 minus into minus is plus 4 whole square, which is equal to root of minus 5 square is 25 plus 5 plus 4 is 9 and 9 square is 81. That is equal to root of 25 plus 81, that is root of 106 units. So this is the distance of AB. Now just see. The distance of any point A from the origin is given by root of x square plus y square. So if I say that a point is here, that is A, and the coordinates of this point is x, y, and it is, we need to find the distance of this point A from the origin, and you know the coordinates of the origin is 0 and 0. So to find the distance of this OA, we are going to use the distance formula. Then here it will be x2 minus x1, that is root of x2 is x minus x1 is 0 whole square plus y2 is y minus y1 is 0. So it is y minus 0 whole square, which is equal to root of x minus 0 is x square plus y minus 0 is y square. So we get that the distance of OA is root of x square plus y square. So to find the distance of any point from the origin, so the formula is root of x square plus y square. Just see how to find the distance between the 2 points that are on the same axis. If the 2 points A and B are on the x-axis, then AB will be equal to the modulus of x2 minus x1. So just let me take the example here. If I take the 2 points on the x-axis, that is, if one point is here A and the other point is here the B. And can you see here A and B are on the same axis, that is x-axis. So here the distance of this AB will be equal to the modulus of x2 minus x1. That is 5 minus 2, that is mod of 3, which is equal to 3. So to make you understand about this modulus, let me write here AB as I said that order doesn't matter. So here if I take here instead of x2, if I take x1 minus x2, 2 minus 5, so it will come 2 minus 5 is minus 3. So as you all know that distance can't be negative. That is the reason we have used this symbol, that is the modulus symbol, which shows that all the numbers, whether it is positive or negative, it remains positive. So the distance between these 2 points is 3 units. In the same way, if I take the 2 points P and Q on the y-axis, let me take the 2 points here. Let the one point be here P and the other point here as Q. So to find the distance between these 2 points, here PQ will be equal to modulus of y2 minus y1. So PQ will be equal to modulus of y2 minus y1. So if I take the y2 as minus 4 and this minus, and y1 is also minus 2. So it is mod of minus 4 minus into minus is plus 2. So minus 4 plus 2 is minus 2. So the modulus of minus 2 is 2. As I said that this modulus symbolizes that whether the number is positive or negative, it remains positive. And we have used this symbol because the distance always remains positive. So the distance of these 2 points on the same axis is 2 units. To find the distance between the 2 points on the same axis, you can use this formula also. Still you get the same answer. So just see how. The coordinates of this point A will be 2, 0, and the coordinates of this point which is on x-axis will be 5, 0. So if I use the coordinates of these 2 points in this formula, we get root of x2 minus x1, that is 5 minus 2 whole square, plus y2 minus y1, that is 0 minus 0 whole square. So here it is root of 5 minus 2 is 3 square, and you know the root of 3 square is 3. So that's what I said here. Whether you use this formula or this formula, you get the same answer. So in short, you can use the modulus of x2 minus x1 if the points are on the x-axis. The same way to find the distance between the 2 points which are on the y-axis, just let's write the coordinates of this point P, that is 0, minus 4, since the point is on the y-axis. And here the coordinates of this point Q is 0, minus 2. If I put the coordinates of this point P and Q in this formula, then I get PQ is equal to root of x2 minus x1, that is 0 minus 0 whole square, plus y2 minus y1, that is y2 is minus 4, this minus, and y1 is minus 2 whole square, which is equal to 0 minus 0 is 0, plus root of minus 4 minus into minus is plus 2 whole square, which is equal to root of minus 4 plus 2 is minus 2 whole square, and minus 2 whole square is root of 4, which is equal to 2. So here, if you observe, if you have used this formula, you got the distance between the points P and Q as 2 units. And if you use this formula, that is the modulus of y2 minus y1, you get the distance between the 2 points as 2 units. So in short, you can use this formula to find the distance between the 2 points that are on the y-axis. Just see next the collinear points. 3 or more than 3 points, if they are on the same line, then they are said to be a collinear points. So here 3 points A, B and C are said to be collinear if they lie on the same straight line. So here when in the question it comes that prove that whether A, B and C are collinear points or not. So to prove this, you need to show this condition, either of these three. You need to show that the distance of this AB plus BC is equal to AC. So either this or the distance of this AC plus BC is equal to AB, or the distance of this AB plus AC is equal to BC. So if any one condition you fulfill, then we can say that the 3 points A, B and C are collinear. Use distance formula to find AB, BC and AC. So with the help of the distance formula, you find the length of AB, BC and AC, and then just check that the sum of any two should be equal to the third one. If you are not able to show any of these three conditions, then the 3 points will not be collinear. Now let's see the polygons formed by joining the points whose x and y coordinates are given. If 3 points are given, to show that when we join these 3 points we get a triangle, we need to prove that the sum of any two sides, that is AB plus BC, is greater than AC, or AB plus AC is greater than BC, or AC plus BC is greater than AB. AC plus BC is greater than AB. So if you are able to prove any one of this condition, then we can say that the points A, B and C, when we join it together, it form a triangle. To show that the triangle formed by joining the 3 points is a scaling triangle, you need to show that none of its sides are equal. Show that AB is not equal to BC and further not equal to AC. That is, all 3 sides are not equal. Then the triangle will be a scaling triangle. The triangle ABC will be an isosceles triangle if any 2 sides of this triangle are equal. Prove that either AB is equal to BC, or AC is equal to BC, or AB is equal to AC. So if you show any 2 sides equal, then the triangle will be an isosceles triangle. To prove the triangle as an equilateral triangle, you need to show that all three sides are equal. That is, AB is equal to BC is equal to AC. If you show all three sides are equal, then the triangle will be an equilateral triangle. To show that the triangle is a right angle triangle, you need to prove that it is fulfilling Pythagoras theorem. As you know that Pythagoras theorem says hypotenuse square is equal to altitude square plus base square. So if you are able to show the sum of the squares of any two sides is equal to the square of the third side, then the triangle will be a right angled triangle. So here just use distance formula to find AB, BC and AC and put the values here. If you are able to show any one condition, then the triangle will be a right angled triangle. Now let's see, when we join 4 points, which type of polygon is being formed. When the point A, B, C and D are joined, we get a quadrilateral. So now to prove that the quadrilateral is a rhombus, we need to show that all four sides of the quadrilateral are equal. That is, AB is equal to BC is equal to CD is equal to AD. If we show all four sides are equal, then that quadrilateral is a rhombus. To show that the quadrilateral is a square, show that all four sides are equal and even the diagonals are also equal. That is, AC is equal to BD. AC is equal to BD. So to prove the quadrilateral is a parallelogram, we need to show that the opposite sides are equal. If AB is equal to CD and AD is equal to BC, then we say that ABCD is a parallelogram. So now to show that the quadrilateral is a rectangle, we need to show that the opposite sides are equal and even the diagonals are also equal. That is, AC is equal to BD. If opposite sides are equal and the diagonals are equal, then the quadrilateral is a rectangle. Use distance formula to find the length of AB, BC, CD, AD and the diagonals AC and BD. To find whether the quadrilateral is a rhombus, square, parallelogram or a rectangle using these properties. Now let's move to the section formula. Section formula is used to find the coordinates of the point P that divides the line segment joining the 2 points in some specific ratio. Here in this, the ratio given is M1 is to M2. So here, if the point P divides the line segment joining the points A and B internally in the ratio M1 is to M2. So to find the coordinates of the point P, here we are going to use the section formula to find the x coordinate, that is M1 into x2 plus M2 into x1 upon the sum of ratio, that is M1 plus M2. So to find the y coordinate, here we are going to use the formula M1 into y2 plus M2 into y1 upon the sum of ratio, that is M1 plus M2. This is the section formula. With the help of this, we find the x coordinate and the y coordinate of the point which divides the line segment in the ratio M1 is to M2. So now the next point is, if the point P divides the line segment joining the 2 points A and B externally in the ratio m1 is to m2. This point P is dividing this line segment AB externally. So the line segment AB is divided by this point P externally in the ratio m1 is to m2. That is, AP is to BP is equal to m1 is to m2. Here the ratio given was AP is to PB. That is, AP is to PB is given here as m1 is to m2. The point P was dividing the line segment internally here, and but for this part here the point P is dividing this line segment externally, that is AP upon BP is equal to m1 is to m2. So in this condition, when the point P divides the line segment externally, to find the x coordinate and y coordinate of this point P, we use the formulas, the section formula we use, but in place of this positive, we mark it as negative. Can you see here? In place of positive, we are going to make it as negative. Just that is the change in the formula. That is m1 into x2 minus m2 into x1 upon m1 minus m2. That is the x coordinate. To find the y coordinate, the formula will be m1 into y2 minus m2 into y1 upon m1 minus m2. Let's understand this question with an example. Here for section formula, we make use of 4 values. That is the coordinates of point A, the coordinates of point B, the ratio, and the coordinates of the point which divides the line segment in some ratio. So here we are going to take an example where the coordinates of point A is given, that is 2, 1, and the coordinates of point B is also given, that is -3, 6, and the ratio is given here as 2 is to 3, and we need to find the coordinates of this point P, that is x coordinate and y coordinate. So we are going to use the section formula to find the x and y coordinate of this point P. X coordinate will be m1 into x2, that is 2 into -3 plus m2 into x1, that is 3 into 2 upon the sum of ratio, that is 2 plus 3, which is equal to 2 into -3 is -6 plus 3 into 2 is 6 upon 2 plus 3 is 5, which is equal to -6 plus 6 is 0 and 0 upon 5 is 0. So the x coordinate we got it as 0. To find the y coordinate, that is m1 into y2, that is 2 into 6 plus m2 into y1, that is 3 into 1 upon the sum of ratio, that is 2 plus 3, that is equal to 2 into 6 is 12 plus 3 into 1 is 3 upon 3 plus 2 is 5, that is equal to 12 plus 3 is 15 upon 5, that is equal to 3. So the y coordinate is 3 and the x coordinate is 0. So the coordinates of this point P, which divides the line segment AB in the ratio 2 is to 3, is 0 and 3. This is the way we use section formula when the ratio is given. So now let's see how to solve the question when the ratio is not given. If the ratio is not given in the question, in that case the coordinates of the point that divides the line segment joining A and B will be given. Coordinates of this point will be given in the question, and as the ratio is not given, so we are going to assume the ratio as k is to 1 in place of m1 is to m2. So if I replace the value of k is to 1 in place of m1 is to m2 in the section formula, then just see, in place of m1, if I replace m1 with k, then here it will be kx2, plus in place of m2, if I replace that with 1, then it is 1 into x1 is x1, and in place of m1 it will be k, and in place of m2 it will be 1. So it is k plus 1. So x is equal to k into x2 plus x1 upon k plus 1. So this will be your x coordinate. So here for the y coordinate, the same way, if in place of m1 and m2 I replace the value as k and 1, so I get the y coordinate as ky2 plus y1 upon the sum of ratio, that is k plus 1. So here let me take one example. Coordinates of point A is given here as 12, 5, and the coordinates of point B is given here as 4, minus 3. And since the ratio is not given here, so we have assumed the ratio as k is to 1, and the coordinates of the point P is given here as 9, 2. So now to find the ratio, we are going to use the section formula, that is x coordinate will be equal to k into x2, that is 4k, plus 1 into x1, that is 1 into 12, that is 12, upon the sum of ratio, that is k plus 1, which is equal to, and here the value of x, that is, it is given, the x coordinate is 9. So 9 is equal to 4k plus 12 upon k plus 1. So shift this k plus 1 to the other side. So we get here 9k plus 9 is equal to 4k plus 12. Shift this 4k to the other side. 9k minus 4k, that is equal to, shift this 9 to the other side, we get 12 minus 9. So 9k minus 4k is 5k is equal to 12 minus 9 is 3. So the value of k is 3 upon 5. So as soon as we get the value of k, so since k can be written as k upon 1, which is equal to 3 upon 5, so k is to 1 is 3 is to 5. So with the help of x coordinate, we found the ratio, that is 3 is to 5. So even you can use the y coordinate, any one coordinate to be used to find the ratio. Right now I use the x coordinate to find the ratio. So instead of x coordinate, you can solve this question by taking the use of y coordinate, that is 2, to find the ratio. Just let me show you how. So if I use the y coordinate, then y coordinate will be equal to k into y2, that is minus 3k, plus 1 into y1, that is 1 into 5, which is 5, upon the sum of ratio, that is k plus 1. And here the y coordinate is given here, that is 2. So that means we will replace y with 2 is equal to minus 3k plus 5 upon k plus 1. Shift this k plus 1 to the other side. So we get 2 into k is 2k plus 2 into 1 is 2. That is equal to minus 3k plus 5. Shift this minus 3k to the other side. We get 2k plus 3k, and shift this 2 to the other side, we get 5 minus 2. 2k plus 3k is 5k, that is equal to 5 minus 2, that is 3. So the value of k will be equal to 3 upon 5. So the ratio is 3:5. Whether you use the x coordinate or the y coordinate, the ratio remains the same. So in the exam, you can use any one coordinate, either the x coordinate or the y coordinate, to find the ratio. So in the question where ratio is not given, we'll assume the ratio as k is to 1, and with the help of x1, x2 and x, that is x1, x2 and x, or with the help of y1, y2 and y, that is y1, y2 and y, we find the ratio. Now let's move to the midpoint formula here. So when here it is given in the question that the point is the midpoint of the line segment joining A and B, then it divides the line segment in the ratio 1:1. So to find the coordinates of that point P, we'll assume the ratio as 1:1. And using the section formula, in place of M1 is to M2, we are going to replace that with 1:1. So in place of M1, if I write 1, and in place of M2, if I replace that with 1, then we get the formula here as 1 into x2 plus 1 into x1 upon 1 plus 1 is equal to x2 plus x1 upon 2. So finally we get the x coordinate as x1 plus x2 upon 2. In the same way, to find the y coordinate, here in place of m1 and m2, we will replace that with 1 and 1. So 1 into y2 plus 1 into y1 upon 1 plus 1 is equal to y2 plus y1 upon 2. So finally the y coordinate will be y1 plus y2 upon 2. So let's take an example. If I take a coordinate as 4, 5, and the b coordinate as 6, 7, and we need to find the coordinates of this point P, that is x coordinate and y coordinate, and it is given in the question that P is the midpoint of this line segment AB. So in such cases, so here x coordinate will be equal to the sum of x1 and x2 upon the sum of ratio. So the x coordinate will be equal to 4 plus 6, that is 10, upon the sum of ratio, that is 1 plus 1, that is equal to 2, is equal to 10 upon 2 is equal to 5. And to find the y coordinate, it will be the sum of y1 and y2, that is 5 plus 7, upon the sum of ratio, that is 1 plus 1, which is equal to 5 plus 7 is 12, upon 1 plus 1 is 2, which is equal to 6. So we get the coordinates of this point P as x coordinate is 5 and the y coordinate is 6. So this is what the midpoint formula, where we say that the point is bisecting the line segment. Hope the distance formula and the section formula is clear to all of you. In the next video, I will come up with important questions of this chapter. Do like, share and subscribe this channel to get updated with the videos covering important topics. Thank you.